From this warehouse on an industrial estate in Bristol, a team of former military and Formula 1 engineers are setting out to create a car called Bloodhound that will travel at more than 1,000 miles per hour. We're here at the factory to learn more about the car, speak to some of the engineers who are building it, and chat with the driver, RAF Wing Commander Andy Green.
We're going to take the world's most sophisticated race car, which is part Formula 1 race car, part supersonic jet fighter, part next generation space rocket. The most sophisticated straight line racing car in history, and we're going to take it to South Africa this year to do 800 miles an hour as a stepping stone to being out in South Africa next year, 2016, for 1,000 miles an hour.
So when we come to run Bloodhound in the desert for the 1,000-mile-an-hour runs, Andy Green will start the EJ200. The EJ200 on maximum reheat will power us to around 300 miles an hour, at which point we'll fire up the rocket because we need to maintain a constant 2G to 2.5G acceleration.
Accelerating up through 650, 700 miles an hour, shockwaves start to form over the canopy. It gets even noisier. As we get up to 700 miles an hour, the steering settles down because the aerodynamics start to dominate. But as we accelerate up through supersonic and as well as the noise, the handling changes dramatically, and at Mach 1.2, 1.3, approaching 1,000 miles an hour. Tiny changes in the steering and the front wheels. As we turn the front wheels ever so slightly, the shock waves will generate huge side loads. So now a tiny change in the wheels will generate a huge load and a huge response. So I've gone from steering on ice to tiny, tiny steering inputs, all in the space of 10 or 15 seconds as the car is accelerating.
That will power us up to 1,050 peak speed. Through the measured mile, which is where we're timed through, the car will be accelerating towards the middle of the measured mile and then decelerating towards the second half of the measured mile. We will go through that measured mile in just 3.6 seconds. When Andy exits the measured mile, he turns off the taps to the engines and the rocket.
Let go of the rocket, start the deceleration, ease off on the throttle. Now the aerodynamic drag of the car is slowing it down, 17 tons of drag, that's just on 3G. That's the equivalent of driving at 60 miles an hour and coming to a complete stop in 1 second in a road car. It's a fairly violent experience. It is even worse when you've just been accelerating and suddenly gone into a 3G deceleration. Physically and mentally very hard on the body because it's very disorientating for me in the car.
At 800 miles an hour, we then start deploying the air brakes to maintain the 3G deceleration. And then down to about 200 miles an hour, the air brake efficiency starts dropping off. We'll then deploy the wheel brakes, which will allow us to bring the car down to a stop at a point predetermined adjacent to the turnaround team.
The team will swarm all over the car. They now have to perform what looks like a racing pit stop on something with the complexity of the space shuttle so that we're ready again with a jet rocket V8 powered car to set the other half of our world record within 1 hour. It's going to be a busy experience for all of us.
So for me, this is one of the most interesting parts of Bloodhound. This is a 5.5 litre V8 from Jaguar. It's the engine used to power the F-Type R, produces about 550 horsepower. Its job is to drive Bloodhound's fuel pump. That pump will send about 800 litres of fuel into the rocket motor in just 20 seconds. In days gone by, land speed records were set merely for the sake of pitting man and machine against physics. But for Bloodhound, things are different. Its main purpose is to inspire school children to take maths and physics A-levels on their way to becoming the next generation of engineers. As a result, every technical detail of the Bloodhound project is being shared with children at more than 5,000 schools in the UK and South Africa.
We have a huge education programme. The car exists because of the need for an education programme to get school children, predominantly of primary school age, interested in science, technology, engineering and maths. It's a very visible way, it's something to focus our education programme on, it's a very visible thing for children to get excited about.
We're here today to obviously have a look at, have an inside look at what they're doing at the Bloodhound. We do engineering quite a lot at Fairfield High School, right from Key Stage 3 right through to Key Stage 4. It's quite a popular subject amongst all the students, and a lot of students go on to do it at post-16 at various colleges. We try to encourage them to look at all different aspects of engineering, so to be able to come down here today to look at this is just a different perception of engineering, something a little bit more bigger, grand, sort of quite inspirational for the students that they don't often get a chance to have a look at.
For the first time in history, we're going to be pushing out live video and live data to a global audience. We're going to hit the same audience as the Apollo. This is going to be the Apollo moment for the 21st century.
Data and HD video will be streamed live from Bloodhound to the internet on all of the 60 or so runs the car will make between now and reaching 1,000 miles per hour in 2016. To make this possible, a 4G network was installed in Pan, where the car will run. This not only creates a way of streaming the data from Bloodhound as it flies past, but the network is permanent and has now brought the internet to a remote part of South Africa years ahead of schedule.
And what we've been working on is a bespoke network in which we can stream live video and data from the car in real time so the rest of the world can watch with us. On that there is a bespoke 4G LTE network, so the same as you would use on your mobile phone, just really turned up and tweaked for us to use. The car will contain, in the fin of the car, we'll have 4 antennas on each side of the fin. This will allow us to transmit to the communications masts via 4G. This will allow us to get all of the video and the data off the car live. That will then be transmitted from that mast back to our studio, where we can then mix that and get it out to the world so that kids in school can sit and watch this in the classroom.
A lot of people ask, am I going to be scared when I get into the cockpit? I'll be nervous, but not about crashing. We've got the world's most sophisticated, most exciting land speed record car with the world's best engineers and the highest level of safety of any straight line car in history. My nervousness will be somewhat different. This is the first car of the digital age. We are streaming live video from Bloodhound onto the internet. A global audience of tens of millions of people are going to be looking through this camera just here, sitting over my shoulder, marking my homework in real time, listening to me talk through the run, watching me drive and make all of the corrections. And of course, replaying it in slow motion afterwards to see where I got it wrong and how precise I was in each detail. But that's fine, because we're sharing the adventure with a global audience. We're inspiring and exciting people about science and engineering, particularly that next generation of young people, to get them excited about science and technology through the Bloodhound education program and through the live experience of watching the world's largest engineering experiment live as it's conducted run by run.
But Bloodhound isn't alone in its pursuit of the land speed record. Teams in Australia and America are both developing cars to beat the current record of 763 miles per hour set by Andy Green in 1997.
The one thing that's more exciting than breaking your own record is breaking somebody else's. The Australians, Roscoe McGlashan and the Aussie Invader 5, not far from running, we think. The car looks reasonably complete. He just needs to finish the rocket development and get a track ready. So quite a lot of work to do there. The American competition at the other end of the scale, the Lockheed Starfighter with the wings cut off and wheels put on it, which is the North American Eagle, they have already been running at over 400 miles an hour. So they've already got some history behind them, very much hoping we'll see them run in 2015. But my message to both of them, first of all, please do break that record, because it will make our education program so much richer and more interesting. And second of all, guys, get a move on. Bloodhound is going to run later on in 2015. You haven't got long before the world's fastest car is coming to get you. So I really hope they make that. It's another golden age of the land speed record, and it's a fabulous time to show off the very best of science and technology. Can't wait to get started.